हेलो एवरीवन, गुड इवनिंग। दिस इज़ संतोष और आज हम लोग डीप लर्निंग का तीसरा चैप्टर पढ़ने जा रहे हैं। ये तीसरा लेक्चर है। तो इसमें हम लोग जो है परसेप्ट्रॉन के बारे में पढ़ेंगे। तो इसमें बेसिकली जैसा कि हमारा ग्राफ में दिया हुआ है कि इस तरह से इनपुट लेयर है, हिडन लेयर, जो लास्ट सेशन में भी हम लोगों ने डिस्कस किया था डिटेल्स में। लेकिन इसमें हम लोग एक्टिवेशन फंक्शन और इसके जो एल्गो हैं उसको ज़्यादा डिस्कस करेंगे, जैसे कि ReLU है, सिग्नॉइड है, ये सारी चीज़ें। और ये किस कॉन्सेप्ट पे काम करता है, लीनियरली या कौन सा नॉन लीनियरली, या उसमें जो एक्सॉर है उसको भी डिस्कस करेंगे। ठीक है। तो सबसे पहले परसेप्ट्रॉन क्या होता है। द सिंपल न्यूरॉन्स, द परसेप्ट्रॉन इन्वेंटेड बाय द फ्रैंक Rosenbelt in 1957 it is the simplest type of artificial neuron network. It is a binary classification algorithm. Structure of a single perceptron. Imagine a single neuron that takes several inputs and produce one output. Inputs that like x, x1, x2, xn. These are the feature of your data point. For example, to classify an email as a spam, not spam, input could be number of exclamation mark, presence of the word free, etc. Weights. So what is the weights? W1, W2 and WTN. Each input has an associated weight. The weight represents importance of that input. A higher weight means the input is more influential. Bias, an extra parameter that allow the model to shift the activation function to the left or the right, improving flexibility. Think of it as a threshold. Summing function and activation function. The perceptron calculates the weighted sum of its input and add the bias. Z is equal to Wx, Wx1 and Wtx. This sum Z is then passed through an activation function to produce the output. For the classic perception, the activation function is the Heaviside step function and text output y is equal to this 1 if z is greater than or equal to 0, 0 if z is less than 0. In a nutshell, the perceptron looks at the data point, calculates a weighted score and makes a binary decision based on whether that score crosses a threshold. The perceptron's learning algorithm. The perceptrons learn by the iteratively adjusting its weights and biased based on the misclassification. Initialize weights and bias to small random number or 0. For example, training example input and desired output, like calculate the output using the current weight. So it's all about the things that matter in the algo. And these rules are simple initiative. It is the perceptron incorrectly output 0 for the data point that should be 1. It increase the weight for the positive input. It is incorrectly output 1. It decrease them. So it is a simply based on the XOR problem. सो एग्जॉर प्रॉब्लम में हमारा क्या होता है, जैसे कि हमारा कोई इनपुट हमने ज़ीरो लिखा, इनपुट ज़ीरो ज़ीरो दिया तो उसका आउटपुट क्या आएगा, ज़ीरो आएगा। इसका अगर हमने इनपुट क्या दिया, ज़ीरो और वन दिया तो आउटपुट वन आएगा, वन ज़ीरो दिया तो वन आएगा, वन वन दिया तो ज़ीरो आएगा। इस तरह से ये काम करता है। सो मल्टी लेयर परसेप्ट्रॉन, द सॉल्यूशन टू द परसेप्ट्रॉन limitation is to the stack multiple perceptrons together in the layer, creating a multi-layer perceptron. This is also known as the feed-forward neural network. Key architecture changes layer, input layer. So there are three layers: input layer, output layer, and hidden layer. The layer that receives the raw input feature, it doesn't perform any computational, it just passes the data. Hidden layer, one or more layer between the input and output. These layers are where the magic happens. Each neurons in a hidden layer is a perceptron. Output, the final layer that produces the result, and a regressive value. Non-linear activation function. This is the critical upgrade. Instead of the step function, MLP use smooth non-linear function like and sigmoid. It squashes value to the range between 0 and 1, good for output layer where you need a probability. 10. Squashes value to the range between -1 and 1, 0 centered often performs better the sigmoid in hidden layer. So there are the algo is sigmoid is one of them, and there is a function based algorithm. So second one is ReLU, rectified linear unit, the most popular activation function for hidden layer today because it's simple, efficient, and help mitigate the vanishing gradient problem. Why are these crucial? The non-linearity allows the network to learn incredibly complex non-linear decision boundaries. Without them, staking multiple layers would be mathematically equivalent to the single layer, defeating the purpose. How an MLP work? Forward propagation. So there are the forward propagation data flow from the input layer through the hidden layer to the output layer. The input value are the fed to the input layer. Each neurons in the first hidden layer calculates its weightage sum of the input and is biased and passes it through its activation function. The result become its output. The output of the first hidden layer become the input of the next layer, either hidden layer or output layer. This process continues until the output layer produces a final prediction how an MLP learn back propagation. This is the core learning algorithm for NLP. It is a way to efficiently calculate the gradient of the loss function with respect to every weight in the network. The process happens in the two main phases, forward pass or backward pass. The batch of the data is a pass through the network and the final output and the total error are calculated. Backward passes. The error is propagated background through the network from the output layer to the input layer. As it goes back, the algorithm calculates the gradient, and this tells us how much a small change in specific weight would affect the total error. Weight upgrade, an optimization algorithm, and uses this gradient to update all the weights and bias in the network. And the rule is essentially nu is equal to the word plus minus gradient. This rule is designed to the lower the error for the next forward pass. So this is the comparison table where we can compare the things, and in summary we will see that we can see that and these are the multi-layer perceptron is a network of many perceptron organized in the layer using non-linear activation function. The architecture allows it to learn highly complex and non-linear relationship in data through the powerful propagation algorithm. And MLP are the fundamentals building block of the deep learning models we use today. So this is all about the perceptron, and in next we will discuss about the next picture, next slide, single layer neural network algorithm. So in this neural we also call the propagation. See, propagation, forward propagation or backward propagation. So it is also the based on the input hidden layer or output layer based on the formula z is equal to w dot x plus b or a is equal to activation. And same way backward learning and training is for input data calculate and output prediction. So it's in the propagation we will discuss the forward propagation and backward propagation. So it's see the forward propagation make a predictions, calculate loss and measure how wrong the prediction is. Backward propagation calculate how to update weights, and weight update actually adjust the weights. Let's walk through this with a simple three layer neural network. Three layer. So three layer neural network is input layer and hidden layer which has 2 and 3 neurons. Output layer is 1 neurons. So forward propagation is a process of passing input data through the network to get a prediction. Mathematical process for each layer, linear transformation, text z is equal to w into a plus b, where w weight matrix for the layer, a I minus 1 activation from the previous layer, and b1 is the bias vector for the layer, and z1 is the pre-activation value, activation function, text, where g is the activation function, ReLU, Sigmoid and Tanh, etc. Step by step example. Let's use a specific value. Network architecture, input x is equal to 2, 3. Hidden layer 3 neurons, ReLU activation, and output layer 1 neurons, sigmoid activation by for binary classification. C, and true level y is equal to true is equal to 1, weights and biases, and text w1 is equal to 0 0.1, 0 0.2, like that. W2 hidden layer are there, and text is there, predictions and loss calculation. We need to measure how wrong our prediction is using a loss function. For binary classification we use binary cross entropy. So this is the text and chain rule. So output layer gradient, and second one is hidden layer gradient, and the next one is weight update, and text forward pass, backward pass, output layer gradient, upgrade weights, forward pass, backward pass, and gradient flow backward efficiently, and batch processing. See, so this is the gradient calculation laws, forward backward propagation, and etc. So these are the all about the neural network algorithm forward propagation and backward propagation. And the third one is gradient descent variable. So gradient descent variable, what is this? Variance based on the data users and advanced adaptive variance optimizer. See, the and this gradient is overview the optimization landscape. All gradients descent variants aim to minimize the loss function by updating model parameters, but they differ in how much data they use and how they updates the parameter. Batch gradient descent, vanilla gradient descent, how it's work, uses the entire training dataset to compute the gradient and performs one update for epoch update rule, Python for the epoch in the range, and gradient weight characteristic, advantages and disadvantages. When you need precise convergence, stochastic gradient descent and updates rules. So mini batch gradient descent and update rules, concepts, and Netrov accelerated gradients, see, and ADA grade, RMS props and ADAMS, and third one So default choice, Adam works well out of the box for the most problem, good starting point for any architecture. So there are the batch, GD, stochastic, mini batch, and in advanced adaptive variant, momentum based adaptive learning rate, and there are momentum and ADA grade, RMS props and ADAMS, summary optimizer, data uses, momentum based, and key characteristic. For the research of the final turning, SDG with the momentum can achieve better generalization with careful tuning, often reaches lower final loss than adaptive method. For space data, ADA grant Adam handles influent feature well. For RNN and LSTM, RMS props and ADAMS work well with the current architecture. Learning rate scheduling is step decancing reduce learning rate by the factor every n epoch. Exponential decays and continuous reductions, cousins annealing, periodic restart can help escape local minima. See, and create sample data. Example optimizer implementations and these things. Compare the optimizations. So this is all about the gradient, and the last but not the least is activation functions. Sigmoid, Tanh and ReLU. Sigmoid, Tanh and ReLU. So this is the formula based sigmoid algo and Tanh and ReLU, zero centered formula, zero centered, very centered, vero centered, common use case and functions. So why we need activation function? Without activation function, a neural network would just be a fancy linear regression model. Activation function introduce non-linearity, which enable the network to learn complex real world patterns. Sigmoid function, mathematical definition, text and characteristic. See, and so this is the activation function like ReLU implementation. So this is based on binary classification, multi-class classification, regression, and if experiencing dining ReLU problem, RNN and LSMT, sigmoid deactivation, tick devariance, ReLU derivation, and etc. So this is totally based on as said probability output, drawback, vanishing gradient, and range between the first sigmoid is 0 to 1. See, 0 to 1, and this tech is 0 centered and Stocker gradient range between -1 to 1, and ReLU is 0x and range between 0 to infinite, so 0 centered. So this is all about the एक्टिवेशन फंक्शन. तो ये हमारा जो था वो डीप लर्निंग का लेक्चर 3 था, जिसमें कि हम लोगों ने एल्गो, फंक्शंस और काफ़ी चीज़ें डिस्कस किया. अब नेक्स्ट वीडियो डीप लर्निंग का होगा लेक्चर 4, जिसमें कि हम बाकी चीज़ें डिस्कस करेंगे. ठीक है, और इसमें आपको ये लेक्चर कैसा लगा लाइक शेयर सब्सक्राइब करके बताइएगा, और नेक्स्ट जो टॉपिक है वो किस पे बनना चाहिए ये भी आप लिख के बता सकते हैं. Till that time, watch this edu world and bye. Jai Hind, Jai Bharat.